Hello everyone, welcome to the new lesson. And in this lesson, we are going to see the application of correlation analysis to find the correlation between the numeric variables to get some relational insights to see is there any relationship between any numeric variables. However, you can see our question is find the relationship between order value, cost, and refund amount. So we want to see how the order value reacts when there is an increase with in cost or refund amount. However, we can also measure how refund amount behaves when you can see there is a decrease in order value or cost. So you can define such relationship in your numeric variables after completing this lesson. So we'll go to ChatGPT and we'll ask. So we can say, right, give me a Python code for calculating correlation and visualize in a correlation matrix. Okay, so I can also define the number of variables I have. So I will define that for three numeric variables. Now run the command. So here you can see the code. At first, it imported the necessary libraries and created the sample data. We can ignore it. We need this tiny line of code to calculate the correlation and these lines of code to visualize the result. However, you can see the correlation underscore matrix is the variable within which the result of correlation is loaded. You can see the df is used to on which the correlations are calculated. We will use the final df obviously, and the dot corr is a Python method to calculate the correlation among the variable in a particular data frame. However, in the next lines of code, you can see that the figure size is defined, then the heat map is used, and here the data is correlation matrix, the title is set, and finally the plt.show. So now you can copy the code, go to Jupyter Notebook and paste it. We have to change it to final underscore df, and we have to filter out our variable names because we are not measuring the correlation on our entire data frame. Rather, we are measuring the correlation for order value, euro, and for cost and for refund. Now it is okay. So let's run the code. Here you can see the correlation matrix. So in a correlation, the maximum number of coefficient value can be 1 and the minimum number can be 0. So for our cutoff point is 0.5. You can define weak relationship if you can see any correlation coefficient value is going near 0 and most importantly below 0.5. Or you can define any correlation coefficient as a strong correlation if you can see the correlation coefficient value is going towards 1 or specifically you can say higher than 0.5. Or if you can see any correlation coefficient around 0.5, you can define it medium correlation relations. However, you can see the correlation matrix. If I define the relationship between cost and order value, you can see the relationship is 0.99. Very strong relationship. You can also see the relationship between refund and order value is 0.93, which is also very strong. And similar for others. You can see the relationship between refund and cost is 0.92. In correlation, you can get two types of correlation value. One is positive, another is negative. If you can see any minus sign beginning the correlation coefficient value, it will indicate there is a negative relationship between those values. Or for any positive value, you can say there is a positive relationship between those values. Suppose you can see a strong positive relationship between refund and order value. That means you can say when the order value increases, the amount of refund increases. Or you can say when the order value increases, the cost is increases. But suppose, just suppose and think that there is a negative relationship between refund and cost. Then you can say when the cost increases, the refund decreases. So this is how you can measure the relationship. So after all, you can see there is a relationship between the more you get the order and the more cost you bear, the refund will definitely increase. So that's all for now. Thank you.